to find ways to be able to get things done in the most, I will use the word, cost effective way, right? So in that case, right, in that case, looking for um, the most cost effective way to do things, to carry out things as fast as possible. You may not be able to, because when you are doing this, you are doing a lot of trade-off. You are thinking between two things or more than two things. Or should we use this particular service or this one? Which one will be best? Should we use an auto scaling group and things of that nature? If you don't have enough time to, because these are things that you take time to think about, you research about, you look at documentations so that you can make the best decision for it. And if you are shipping features very fast, there's a lot of speed. You might not have a lot of time to be able to do that, and that can lead to you making poor decisions when it comes to cost. And the fourth thing, right, is the changing requirement over time. You can have an architecture today that suits what the product looks like today, but in the next few months, everything might have changed, and you have to redesign and evolve basically. So there's that constant change in the startup environment. So looking at these four things, right, these are the things that eventually brings about most of the mistakes that engineers make very early, and these mistakes can pile up depending on how bad it is, and they can cost a whole lot. So let's look into it, and I'll just share a few use cases. Okay. All right. So the first mistake that I have seen is over engineering too early, and I think this has probably been said over and over and over again, but is what's been said again and again is very important, because in a startup environment, as an engineer, as a DevOps engineer, likely most times you just, depending on where the product is, probably you are still at the pre-launch phase, right? You've not even launched. Let's take that for instance, right? You don't have business using things like Kubernetes, even, or you just need, let's say, VPS, or let's say an EC2, what's a simple solution? An EC2 with let's say an Nginx web server and a database, something simple and basic, right? If you are over engineering too early, there's a lot of things that comes into it. There's a cost that comes into it. There is the overhead that comes in, because you have to be managing a whole lot of things. And just imagine a startup using, like, let's say, things like Kubernetes, because it sounds very, it's what you hear a lot, in on the media. Kubernetes is awesome and all of those things, EC2, Agro CD, all of those cool stuff. They are important, but you must be able to understand where exactly they fit, where exactly they will be useful. Most of these technologies is the best fit for organizations that are growing, that are large, not startup environment. So in a startup environment now, like I said, if you are just at a pre-launch, whereby you've never validated your product enough for you to think that, let's say, this is what the users want or what they would love, and we can keep building and adding more things. At that time, just use an EC2 or use a VPS from most of a lot of these providers, and you are good to go, right? You can use even the free tech, the free options, and things like that. Using things like Kubernetes is, you don't have business with it. So over engineering too early can cause a whole lot of issue, because and I can understand why, because deploying services on Kubernetes, you feel like an engineer, you feel like you've done something cool. But to be honest, the best solution is actually the simplest solution for that use case. You don't need to do something drastic to actually achieve your results, right? So the impact of this particular mistake, now, as you can see here, is that you have an increased overhead, meaning there's a lot of things to manage. And in most cases, the startup team doesn't have enough hands on the Kubernetes mostly. So because of that, your development will be slow, right? Which is not actually adding up to how a startup environment is actually meant to be. You are meant to actually ship very fast, build new features as fast as possible, and things like that. And your cost is going to obviously it's quite simple. Everything, this is just the way it works. Every organization you see today, no matter how big they are, they started from somewhere. They started from a small service, and then they began to improve as they face a lot of issues. Let's say probably issues of they faced another issue, serving a lot of users simultaneously. So they had to move from the monolithic architecture to the microservice. So you should get to a point whereby you are probably encountering an issue to evolve to another one. So that's the way it's actually every improvement in the technology came from a, let's say, a problem that the engineer, it is your role to be able to do a lot of research, do a lot of even ask senior engineers, do a lot of thinking, right, to be able to see that if we continue with this kind of architecture, and we have more customers in the next few months, what are the things that we would likely need? So you think ahead, you foresee what's going to happen, and you plan for it, right? That's the best way to work about that. So for startup, depend on how much money they are willing to definitely use the word use, right? So you can use managed services actually, because managed services will allow you to be able to uh, focus on building the futures, focus on just deploying stuff rather than managing a lot of heavy lifting. You have managed services like on AWS, you have like ECS and a lot more. So I think that would be a way to fix that, and that's a mistake that I've seen over engineering to where there's no need for it. Okay, you can begin to definitely drop your questions if you have one. I will go through it immediately we're done. All right, let's go to the next one quickly. All right, so monitoring gaps. Yeah, this is very important because as a startup environment, you are feeling like some things are not needed at this point, and which is very, 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 very bad because you would definitely in a way one way or the other forget if you don't if you don't begin those practice when you start when you start things like even putting in your own structure of PPCs and subnet and things like that. If you think of monitoring as, oh, after I've deployed everything, we'll not integrate monitoring into it, observability into it, there is tendency that you might forget, and you may not even put a lot of effort into doing it properly. So it's very important that as an engineer in an environment which startups, it's important that from the onset you look at metrics, logs, alerts that are important, because there are some that are not necessary and are important to the application, and you will discover this by obviously what the end users are experiencing. So things like latency, how fast are users able to access the application, things like error rate, how many times as a user tried to access this application and they were not able to access it, and things of that nature. So that would define what you will put in your metrics log for your monitoring and observability. So it's important to implement monitoring. This is something that startup environment obviously overlook and just think, oh, we'll do it later. We'll just do it later. It's not really important now. Let us push out the new feature as quick as possible and let's move on. Right. So the fix to that is implement monitoring before production and track health metrics, set actionable alerts, not just unnecessary alerts because they are unnecessary alerts, right? And I've explained how you can identify those actionable alerts, right? You are able to identify them by what users are facing, because whatever you are doing as an engineer is to basically help the end users, the customers accessing the application, right? Eventually, if whatever you are doing does not add up or does not have a business value, then you are basically not really doing anything, right? So that's that about that. For the third mistake here, I've put SCP, and I think some of you might be thinking that, oh, these things are very common. I don't think anybody should make this mistake, but honestly, these are the mistakes that I have seen and I've heard about continuously. We hear about them every time when there's a breach and all of those things. It's just all these simple little things that are meant to have been probably put in place, or are meant to have not have been put in place, that just that can cause a lot of issues. Let's say hard coded credentials. There's nobody. I think every engineer should know that you should not hard code any credentials, right? If you You want to store your credentials, you should store them services like secret manager, in a place whereby you can retrieve them and use them in runtime, right? So things like API keys, password should never be committed into your repo. I think a few months ago there was this old news with, I think, was it 3D, a lot of applications that were that were compromised basically because of let's say password, a key. And I think the beautiful thing is that you can use services like Secret Manager. I've said that. And if you are trying to, let's say, authenticate with a cloud provider, and let's say your GitHub action, you can use the OIDC authentication method, which does not allow anything to be put on your GitHub repo. So you can look into that as well. So this is very important. Another thing I can talk about credential is, like I said, a proper engineering practice is not just to solve issues when they happen. Obviously there will be issues that will happen, right? That's how it is, that's how it has been, there will always be. But you should be able to, when issues happen, you should be able to understand why they happen, what caused it, and how to avoid them from happening anymore again, right? That's how you think as an engineer. So one of the ways you can avoid add coding credentials in your GitHub repo is by using there are a lot of tools that you can actually use. A few of them that comes to mind is you can use this pre-commit, right? Pre-commit hook. That basically when when anybody's trying to push any change and it has hard-coded credentials, it does not allow that push to get into the repo. Basically, there are a lot more tools. I can't exactly remember them on top of my head right now, but there are a lot of tools that you can use to avoid that instead of trying to now remediate when it has happened. And the best way to actually use your secrets is not to have them baked in let's say in your code, your application. No, you should have, let's say, an external service where you store the secret and you retrieve it at runtime. All right. Okay. All right. So the fourth mistake that I've seen is disaster recovery. And remember that this is tailored to a startup environment, right? So there is this old notion, like I've said, right? You just want to push out the new future. Let's see. Let's keep going. Let's keep going. And this is when you come in as an engineer. You come in and think this with them. And I want you to understand something. It's very important that obviously you move as fast as possible. That's why you have things like, let's say, the CI/CD pipeline, where you design it and everything is automated, and a lot of other engineering practice. But all of these things that I explained is something that you should learn so that you can help your team, you can help the company to avoid making some critical mistakes, right? Very important. Okay, so let's go into disaster recovery. It is important to plan for disaster recovery. So this will not be important in your, let's say, your pre-launch state, or let's say after you've launched a bit, right? But it's something that you should plan ahead for, right? You should plan ahead for, if you think for, because if your database, fails, how are you going to recover the data? What is it that you're going to do? There are questions that you should ask yourself as an engineer. If this component fails, for instance, what would be the effect of this component failing to the whole architecture, to the whole organization, to the whole company, to everything, to the whole product? What would be the blast radius? You look at the component that makes the architecture and think of, if you remove this particular component, what would be the effect? And then that will help you to design a more resilient systems. So for database, you need backups, definitely. Every organization needs a backup, no matter how in code small it is, or let's say cost effective, you need a backup, because it's not a matter of if it's going to happen, it's a matter of when it's going to happen. And the truth is that no system is 100%. There is always failure in one system or the other. But what makes it different is you understanding that there would always be an issue one way or the other, and thinking ahead of those issues and being able to plan ahead of the issues so that when they happen, the blast radius is limited, right? And even when they happen, there's a way you can probably roll back, or let's say your data is still safe in one region or one availability zone, as the case may be. So backups uh, is not something you decide. It's something that must be available, especially in, let's say, startup organizations whereby you are working with patient information like healthcare, fintech. But generally, in any organization, that should be the case. You should have backups readily available. So the fifth one is manual deployment, and yeah, this manual deployment is going to basically slow down the thing, and you want speed as much as possible, right? And another thing with manual deployment again is the fact that if you are running commands over and over again, there's tendency of you making a mistake because you can forget a command, you can type something wrong. It happens, right? So to avoid that, you just have to automate it by having your CI/CD pipeline, be it in GitHub Actions or whichever pipeline, GitLab CI/CD, wherever, right? You automate those tasks, those steps, stages that you need them to run, that needs to be run or that needs to be executed every single time. Automate them, have them down, and you can plan how it should be triggered, depending when you push to main or things like that, and it runs every single time. So you are the system is actually like away from, even though you can review, you can check, but those automate those manual processes have been automated. So it's very important. I don't know any startup environment that doesn't have at least a basic CI/CD pipeline is actually slowing down developers' time, because when developers push new changes, they want to definitely see how that changes looks, even though they have probably tested it in their dev environment. They want to see how it looks quickly as possible, and you don't want a case whereby you your role as a DevOps engineer or cloud engineer is you are like tied to your developers. They need to call you every single time. No, you don't want that, right? You want to build a system that allows their work to be more efficient. So when they make a new change or they build a new feature, they push the change in few minutes. They see what they've been able to work on. That's in the dev environment before they are able to, let's say, push to, let's say, stage or prod, as the case may be. So that's very important. Okay. All right. I think this should be the last one. There are a lot more, but I had to like just concise it for the time we have, right? So some of the weak security practice, right? Security is obviously very important, very important. I think that's one of the most important thing in any system. Security, right? Who can be authorized into the system? How can you identify who is who? Authentication and authorization, very important. So I some of the things, right? Some of the ways you can put in security is by enabling multi-factor authentication. It should be enabled. It should be enabled. So in the AWS ecosystem, because I'm more conversant with that, I've worked with it for a while. So you probably, when you create a root user, you 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 basically, sorry, you enable MFA with it, and basically put it aside. Then you create an IAM user, like a root user, an admin user, which you use to do specific things depending on what you want to do. So you have your MFA. So that basically makes your system more secured. So if by any means anyone is able to get, let's say, your username and password by any means, they will still need to go through the MFA, which is definitely only linked to your device, right? Let's say your phone, but basically that makes it more secure, right? Least privilege is very important. It's a rule that applies in every organization. The least privilege, and the idea of least privilege is such that you only grant access, or you only give permissions to people, or let's say to people in specific roles based on what you want them to do, right? You don't give developers admin access to your CI/CD pipeline or your prod environment. They don't need that, right? They don't need that. You can give them a read access to see what is going on, to the log to see what's going on, but you should not have execute or write access in any way. So basically giving access on the only permissions that are required to do specific things. And that was not, I think that was not actually it doesn't actually include people, right? Let's say developers, QA engineers, product managers. It does not include them alone. Actually, also include roles, because you can create roles, right? Roles to do particular things. in a particular application, right? So, if for instance now in the case I'll use a particular use case, if you're trying to authenticate your GitHub action workflows with, let's say, your AWS in this case, right? And in your workflow, there are certain things you want to do, and those things requires a level of permission. So let's say you want to deploy to, let's say, ECS, or let's say Kubernetes, right? You need a particular permission to deploy to it. You need some EKS admin permission and things like that. So you definitely create a role, right, in AWS, and in that role, you attach that permission to it. But the idea is that you only attach the permission it needs for the job it wants to do. Right? Because if you attach more than that to it, one way or the other, without you even thinking it will happen, your, let's say, the pipeline might run certain things if you just give it more permissions, and it might cause a lot of issues. It has happened, right? And it's still happening. So the best practice is to give it a least privileged access, right? So also encrypt. It's very important to encrypt your data at your sensitive data at first, be it in your database, be it whatever. It should be encrypted, right? So that even if somebody at some point, let's say, bypasses, they won't be able to get anything because the data is encrypted. All they will just see is a bunch of gibberish that doesn't make sense, right? So these are some few things, right? And I just put in here. There are a lot more than this, and a lot more than this. Let me just see a little bit. Okay, I think we still have a few minutes. Okay, let's keep going. I want to check. Okay. I can see some questions. Just keep them coming. I will definitely go through them as I'm done. Okay. But let me quickly walk through this. All right. So if you notice, more of the thing that I've been saying is not more of something that has to do with, you know, writing command. Obviously, for you to implement these things, you have to obviously, write commands and all of those things. But the idea is that you moved into, it brings you as an engineer into a product level thinking, right? Because that's one of the things that differentiates a senior engineer from a junior engineer, the way you think. Because in many organizations, the senior engineer is not usually writing code or implementing all of these things. They think, they read a lot, they think, they look at the system, they identify loopholes, what can happen, think ahead of time, right? And this is actually a very important skill to build. So thinking in system and not tools is very important. It's very important. So personally, I think I've said it before, but personally, the way I work around this is to, if you are trying to implement any new solution, no matter how simple it is or complex it is, just draw a simple architecture. That doesn't have to be anything complex. Just a simple architecture of what you want to do, how traffic flows from one place to another, what to connects to what to, and something of that nature. That just, it gives you a visual representation of what you want to implement at the end of the day. And when making such decisions, right, there are a few things to look at, right? So I've made a diagram here. The first thing, right, you can see here is that you have what happens if this service fails. I talked about that earlier. So if you draw the architecture, you have different services connecting to each other. One of the ways I work around is that you kind of just circle a particular service and ask yourself, what happens if this service fails, right? Is traffic still going to be routed to the application? What exactly will happen? How disastrous is the change going to be? It's very important because that will make you to think that, okay, what can we do? Because this can actually happen. Can actually happen. So you think that, okay, if this happens, what fails? And if something fails, is there any way we can actually, work around it to make it more resilient, right? So you can think of it like, let's say you have, and this can come in, let's say you have like two availability zones. If one availability zone fails, your traffic is routed to the second one, and you can go more deeper than that, right? So I'm just going to the second question. How does the traffic flow through the system? Is very important. So from your, let's say, from the browser that the user is using to, let's say, to the DNS service in the Route 3 or whatever is being used, to the CDN. You think in that way. That's what architecture does for you, and it's something that has helped me a lot, and I can recommend for anybody. Draw an architecture of what you want to do. Think that way, right? What are the dependencies that exist? So there's always a downstream and an upstream, right? In any architecture. So basically, what does this application rely on? What does it depend on? What is the downstream to it? So your, let's say for instance, like your load balancer definitely depends on your EC2. If your EC2, or let's say if your application is in your EC2, or let's say your ECS, wherever you deployed it to, if it's not deployed there, if it's not working there, your load balancer cannot route any traffic to it. So you look at that. What are the dependencies to this particular uh, component, to this particular service? It gives you a better view of how you can think and how you can make more practical decisions. So another thing is, decision what does this decision affect cost? How does decision affect cost? Sorry. So I've said it earlier, cost is a very important part, right? So you want to think, definitely you've done your research to see that this service, obviously this service takes, let's say, the range of this cost to this cost per month, depending. You analyze all of those things, you look at the cost, and that helps you to think of, okay, if you have another service that can do this same thing, right, and it's less and can still obviously the same, we can still use that at this point in time because we are still a startup and we are still growing, right? That is where that cost-effective mindset comes from, and it still boils down to things like creating alerts, cost explorer, and creating alert for, let's say, if your cost is on 50%, 80%, just to track your cost, right? Okay, how quickly can we recover? This is a question of reliability. How reliable is the system, right? How quickly can we recover? Because the question is not actually if something will fail. Something will surely fail. The question is actually how quickly do we recover if something fails? Because something will always fail. No matter how big the organization is, how good the engineers are, something has failed. AWS have had, downtime, outages, Azure has had, a lot of them have had. So it's not, the question is not, the question now shifts from will something fail, or how will something fail, to how quickly can we recover if anything fails. And you can definitely be able to identify this by, looking at the question that says what happens if this service fails. So if you look at each component, if they fail, and you plan how to work around it to recover fast, then you definitely have answered this question as well. The question on reliability, to build a more resilient system that no matter what happens, right, users are not affected or are affected in a little way, right? And the last one is what breaks if this component changes. Very important. So I would have loved to put up an architecture here, right? Let me see if I have one. Probably towards the end, right? But the idea is that what exactly breaks if, let's say, this component changes. So let's say if you don't have your load balancer, again, what changes? Traffic is not being routed to where the application is deployed. That's an issue. So how do you work around that? Is the question. That question in itself makes you to begin to think, oh, what do we do? How has it been done? Begin to make research on how probably companies, organizations, or teammates have probably worked around that scenario. If not, you can do your research to learn how people work around that, right? Because majority of the things that you come across, not all, people have come across it in different organizations, and so some organizations have been very generous to have their own blog where they write their experiences and how they solve those issues. So you read all those blogs and all of those things. Okay, so that I can answer question. Let me just go on through this. Okay, so just a quick checklist I have here, right? It's very important that you use infrastructure as code, right? Even if you are startup environment, at least if you have launched and you are growing at a good pace, infrastructure is as code is the go to go. I don't think there's an organization that is not using infrastructure as code because of the benefit it brings, right? Second one is that you have a separate environment, very important. So you have your dev stage. You may not be able to have three at an early stage, but at least have more than one. You shouldn't be, let's say, trying to create a proof of concept in the same place you're trying to, where your production is. If you are trying to in the environment, you are testing things out and seeing how well they work, under different circumstances. After you've done that, you can now simulate that staging, and if everything works there, then obviously you can now deploy it to production to make sure that everything works as fine as possible. Mm, Monitoring, we've talked about that. It should be configured before launch, not after. Secret, you securely manage least privilege and first. Very important as well. And automated deployment, your CI/CD pipeline, validation tests, yes, because you want that to be automated. You don't want to manually do them, right? Because if you manually do them, you are wasting developers' time, definitely. And then we talked about backups. Runbooks are also important, right? You can begin to create a runbook in a startup environment when you begin to face issues. So the idea of runbooks is when something happens, what are the steps to be able to, resolve them? Just a detailed step to resolve certain issues when they happen. Yeah, cost review. Yes, it's very important to review cost periodically. To be honest, I think I kind of saw a cost on my account, and I'm like, oh, I saw this cost. How did I forget about it? Right. So it's important that you set alerts and see your costs so that you don't just wake up one day and see that your whole credit or cost has skyrocketed and you're like, how do we resolve this? How do we do this? It's very important. Okay, so the final lessons here for this whole session is that no matter what you're doing, right, start small, right? Especially when you are working in a startup environment, just start small. There's no point, there's no trophy for a person that did a complex system or the most complex system. What people are after is the result. Is it working? What users are after is, can I access the application? So use the most simple, approach that you need at that point in time. And if you need to scale, you need to make it more complex, no problem, but build gradually. And discipline over tools, very important. You need to have an operational discipline of understanding your use case, understanding your team. I think Prevost talked about it in the session. Your team, your use case, and based on that, that will determine the kind of solution that you would use. Right? There's no one best solution for any use case. Right? You study your use case, and based on that, you research on which solution is best for it. So reliability is not an option as well. Not an option. Your system should be reliable. That's one of the ways that the users trust you. This system reliable. Can I come anytime to carry out an operation on this platform, and then I will get a response? Yeah, this is very important. So I've said it. Your cloud DevOps engineering knowledge is as important as much as it's actually enable business outcome. If it's not doing that, then you're not really doing anything. So because that's the goal eventually at the end of the day, is to help, like for instance, support the growth safely when, let's say, you are onboarding new users, right? And it's to be able to help team work faster. That's the whole concept of DevOps at the end of the day. So whatever you are doing, whatever you're learning, whatever you're trying to implement, think of it, how does this, enable the business outcome at the end of the day? All right, so I think I will go on to answer questions at this point. Let me see. I will just check around. Okay, I can see a question from Ramya, if I'm not mistaken. How do you balance not over-engineering and creating room for your infrastructure to be able to grow? Okay, thank you for that question. So the way you work around that is simple. You, depending on where you are, right? So I will take a use case right now. I will take a use case of what I've discussed in a startup environment. Let's say, for instance, a basic infrastructure that are having in, let's say, pre-launch, let's say an institute with, let's say, a web server with the data, something basic as that, as simple as that. If it does the work, it's good enough. So in that case, right now, you obviously you don't intend to remain with that infrastructure because you believe that you are anticipating that your infrastructure, your application will grow, you have more users onboarded and things like that, right? There's an estimation. So the idea is that you plan ahead, right? The idea is that you plan ahead and you build on whatever infrastructure you have. So, and that's why it's important to build your infrastructure when you're starting in a way that you can build on top of it, right? Even if let's say your application, for instance, if you're having a monolithic application because you're a startup, which is fine, should be able to build it in a way that it is modular, meaning you can break it when you need to scale into, let's say, a microservice architecture, right? So the whole idea of it is that you start where you are, you plan, and you build your infrastructure, your application in a way that you can add to it, you can build on top of it, right? I hope that answers the question. I can see a question from, is it your slide for mistake 2? You spoke about ignoring certain metrics. What do you mean by metrics not being important? Oh, all right. Thank you, Charles, for that question. So yes, there are, if you notice there, I talked about actionable metrics. So not all metrics are important. So, and I explained that the metrics that are important, because I just want to just go straight to the point. Metrics that basically affect your users. So anything you are doing, basically, it doesn't matter what you're doing. You are at the back of the mind, are thinking of the business outcome. So I also let me give you a few list of the actionable metrics that you can look at. So look from a user's perspective. Or I'm trying to access an application now, and it's taking, let's say, more than, let's say, a minute or so to access the application. It's not meant to be. I should be able to access an application in microseconds, right? So that's latency. What is it? That's latency, the time it took for you to access an application. That's latency. So that's a metric that you look at in-house as an engineer, right? You track that metric. So, and another one that comes to mind, right, is your error rate, for instance. So let's say you have a payment gateway sort of a thing that people are trying to make payment, and then let's say they're having issues from time to time. That's something that you track. How many, let's say 500 error or 500 or 505, 500 error, server error, and people have when they are trying to make this, transaction, things like that. How many transactions failed? You think of it, and those are the things that you track, because those things directly impact the users. So there are metrics that are not important, or let me say they're not important to the users, or they're only important internally. There are metrics like that. So for instance, you have metrics like, let's say the CPU utilization is not entirely directly in quote important to the users, right? You don't need to know that, but it's important to you internally. You need to be able to look at the metric, look at your CPU. If the utilization is being utilized, let's say it's over 70% and things like that, so that you can scale up and all of those things. I hope that answers the question. If it does, you can just type and let me know. Okay. Yeah, definitely. You can join the WhatsApp group here. Yeah, if you want to. It's very interactive, to be honest. So, but okay, I can answer that question here. As a young developer from Kenya, I've noticed that AI is accelerating both software development and cyber attacks at the same time. Our modern DevOps team adapting their security strategies to defend against AI-powered threats without slowing down innovation and startup growth. Okay, I think it's an interesting question, because we've all seen how that, after the whole AI buzz and, I'll call it noise. Actually, AI is helping, but there's a whole lot of noise to it as well, to be honest. And then we've seen the effect. How that there've been a lot of breaches, there've been a lot of attacks, things have been compromised. So I think the simplest way I will answer this question is this. The idea is AI is actually a tool, either with any way you want to see it. Let's say you want to use it to, track some security breach in your infrastructure, whatever you want to use, is a tool. So you are definitely trying to incorporate it into what's already existing, right? The infrastructure that's already existing. It doesn't matter what you want to use it to do, whether to use to scan things, whether you use it to, let's say, analyze, let's say, pull request, whatever. You are trying to integrate it into a system. And most breaches actually happen during that integration, right? That middle of that integration. So one of the things you want to look at is the AI, agent, whatever it is that you want to implement, and study and understand it, because I think a lot of issues happen. A lot of these issues happen because people were just excited about what AI can do, and not thinking about what are the pros and cons that it brings, right, to the, let's say, to the platform or to the product or whatever, to where they integrated it to. I think that was the issue. People were too fast to adopt it. They were slow to think of, because anything that has a pros has a cons, Anything that has an advantage has a disadvantage. So the idea is to be able to limit the advantage that comes with it, and and be able to definitely maximize the advantage that comes with it. So I would say whatever AI is being used, right? Let's say you are trying to have your AI, because you have even AI robots that are created to, let's say, uh, analyze pull requests from different engineers in large organizations. Because if instead of you having somebody there to review it every single time to make a change, to allow the request to be met, it takes a lot of time. So they have like a robot that I'll use a robot. Here's a word. You even find one in the Kubernetes GitHub repo that actually reviews, that does automated uh, checks on your pull request and give you a response before an human being, or let's say a maintainer, actually now, let's say, approve your changes. So look at what you want to implement, that piece of code, because AI eventually is a piece of code at the end of the day. Look into it. You have to study it. Where can there be breaches with this AI if you integrate it to our system, right? Because the security, the security at the end of the day is not just is going into each component, and that's where DevSecOps comes in. You look at different stages, and those stages you look at how to secure each of them so that there's no loophole at all. So if you're trying to integrate an AI to AI agent, whatever it is, you have to make sure to understand the whole, at least the baseline of how hackers can breach it. You secure it at that point, and when you integrate it also, you secure that particular point as well. So that's pretty much it, right? And also very important that you don't grant access to AI agent anyhow, like credentials and things like that. You limit the access. At least for now, their work is to make things more faster, but at the end of the day, you have to approve whatever is being done, and you have to still be able to think through whatever AI gives to you, right? You make the decision at the end of the day. So I hope that answers the questions as well. Okay. Any other question? Let's see here. Okay. We have few minutes left. Any other question? Tara, can you hear me? Can you guys hear me? I hope I was.
Yes, yes, we can hear you.
All right, thank you very much. Thank you for that response. Okay, is there any other question? I just want to be sure. Or let's say in general in DevOps, I would love to answer if there is. Okay, noted.
Giovanni, thank you for the great event that you have provided here, and you have touched really interesting gaps, interesting points of the overall the DevOps culture, DevOps methodologies that needs to, in our brain, that we actually has to memorize some actions, how to understand all this, the engineering stuff. And I'm really appreciated this event. I think there is no any additional questions here, and we have about 5 minutes that we can close this session. Yeah, guys.
All right, thank you very much. Thank you very much. I appreciate the response, and I'm glad that the session was as clear as possible, because that's the goal, right? To make it clear as possible and as simple as possible. All right. So I think if there's no other question, is Tarak still here?
Yes, I am.
Okay.
It's your show today. That's why I didn't come. But I really loved it. When I invite people to talk, it's not about me. It's not about my brand. It's about yours. So what is really important is thank you so much. I really appreciated the time that we spent together. You asked for me, tell me.
As for you, is that what?
You said that if I were present. Yes, I am.
Yeah, I was asking for you because I've not heard from you at all throughout.
No worries.
We didn't hear anything about you, Tarak.
Now it's just
Until the ending.
me. I'm always here, but my goal is like for the community to. Is not about me at the end of the day. It's about you. It's about the emotion that you communicate with the 39 people that are here. But yes, if you need me, I'm here. I've always been here.
Bro, I've tried to complete this session without any capturing. Bro, don't risk like this.
No, no worries, no worries. So what can I do? Tolani, it was a great session, like always. I really, really appreciate it. I learned a lot, especially with you, listening to your experience, reading the slides. I think it was very, very important. And even with who I am, I learned a lot. So I guess that everyone learned. I also shared the WhatsApp community so people can actually come and be with us. But yes, Tolani, you asked for me. What can I help? How can I help?
No, I think we're all good.
Okay.
Yeah,
So,
we're all good. I wanted to hear if you probably have a question or there was one thing in the audio that you wanted to say, as I was, referring to you.
No, for me, to be honest, like I said, it was your show. It's not me who need to, like, even now, I am basically hijacking your show. I don't want to do it. So I'm going back in the back. But yes, it's you and the community with you. It's not about
Okay. Can somebody's asking if they can get a presentation? Yeah, you can, definitely. I would make it available immediately, wrap up this session, which we are almost done. I would send the slides. You can definitely have it. Yeah, definitely. And okay. Yeah, you can go ahead, Kevin. You want to say something? Can you see?
No, sorry, it was by mistake, sorry.
Oh, okay, all right then. So I think one more thing I would just love to say is I think I just made it a culture in a way. For every session of discussion of sharing value, I just love to I just feel like we can at the end of the day people want to go through everything, and I think that's the reason why Ravish is asking for the presentation. So I take liberty to just write an article on everything I talk about, so that you can be able to access it and read on it later if you want to, basically. But that will definitely be available on the university channel, so on the OS platform. If you go to the creator part, locate my name under the articles, you'll be able to find it there, right? But yeah, you will definitely have the link to this presentation on the WhatsApp group. So I think that's it. If there's no other question, I look forward to adding more value and to other speakers in your sessions as well. Thank you very much for having me.
Thank you, Tolani. Thank you, guys, for the great session.
Thank you, Tolani.
You're welcome.
Thank you, Tolani.
Yeah, you're welcome. Okay.